In this lesson, we're going to look at a grade 12 concept, implicit differentiation. Firstly, let's look at the inverse, explicit differentiation, which you're actually well accustomed to. So, you can see a little formula there as well. Generally, you're used to seeing a function or an equation like this. And you would differentiate it. So derivative of y in terms of x. So we can see a little formula here. Take away the power of 2 and multiply it by our coefficient, which is 6x. So we diminish one of the exponents for the variable, and our constant of 5 disappears, and so of course the operator too. That's how you've been doing that. It's a simple example. Now, in this case, and in these cases, the y and the x are separate and clear on one side. But this will not always be the case, and that's where implicit differentiation comes into it. Sometimes, in this next example, for instance, you can solve it both ways. You can do it explicitly and with implicit differentiation. And you may even have two distinct answers or functions for the implicit differentiation answer. But often, as the point of doing this, you will come across a scenario where you cannot do it explicitly, so you must use the method that we're showing today. So can you solve for y? Well, I'm going to do it over here. Let's cancel x on both sides for this this equation here. So x times y equals 1, xy equals 1, same thing. So y, divide both sides by x, is 1 over x, kind of reciprocal graph. If you were to derive that, find a derivative of 1 over x, it would be minus 1 over x squared. I just know that. But you'll solve it yourself there if you know that already. We're moving on to a harder concept here of implicit differentiation. We'll see if that works out in the end of our new method here, we'll say. Implicit differentiation. Okay. We're going to have to use a product rule. So you should be familiar with this. If you're not, I'll go back over it. The product rule is straightforward generally. X times y is equal to 1. I'm going to rewrite that just to make it clear for myself. So we'll start doing this out with the product rule. So u is x in this case. So x times the derivative of the other term. So d over dx. We haven't got it in terms of anything yet. Of y. Plus sign over here. So u times dv. Our other term is y. And we'll find a derivative of x. In this case. Put in brackets. Equals. We have two sides to this. We'll do the same thing with our answer, which is 1, isn't it? Okay. X times d over dx times y. We're going to leave that as it is. D times y over dx plus y times, so we have a variable of x, so that just goes to 1. So this is y. And same with our constant here of 1, it becomes 0. These rules should be straightforward already. And from here we'll simplify. We want to get dy over dx on its own on one side. So divide by, you can kind of get minus y on both sides and divide by x on both sides. I'll just do it out into 2 steps. I'll simplify this down a little bit there. And then divide by, let me just actually make that easier just to look at. Divide by x on both sides, and you'll get your answer down the bottom here. So dy over dx is equal to minus y over x. And that is our answer. We do a little box around that, it's nice. Let's have a look at our original explicit calculation. So 1 over x. 1 over x is y. Y is equal to 1 over x. Replace your minus y, so replace your y here with 1 over x. And you'll see that it's the same thing. You'll actually get this kind of answer here, like minus 1 over x which is y, all over x. If you just can see that there, and you just, if you look at the original answer there from dy over dx, so you can do it both ways, but there'll come a point, like the example below, where you cannot use explicit differentiation anymore, what you've been used to, what you've been accustomed to. And we're going to do this question in the next video. And it has nothing new, so you can do it yourself now if you want. It has nothing new, it has the product rule you might see in a couple of cases, and otherwise you just do it as normally as an explicit function. Okay. That is implicit differentiation. It's a short example just to demonstrate how that works and how it's different to the general introduction to calculus that you've had so far. There's lots of other different ways of doing differentiation with sine, cosine, tan, and logarithms, and so on and so forth. There's lots of formulas, but this is just an example, an introduction to it, just so you can see how it works and why it's used, which is more important. Okay.